All right, good evening and welcome. Just full disclosure, we are recording this meeting tonight, so just for your awareness. So we're here tonight for the Lake Traverse Water Control Annual Update. This is the same presentation we gave last night during Wheaton, and we'll go through the same information tonight, and this one should be posted to YouTube or be available on YouTube the next day or so. So if someone missed it, they can review it later. So we're here to discuss the board's draft operational changes for the water control manual. Right now, we're in our 30-day public review period, so the report's available publicly for you to review and comment. We do ask that the comment period closes December 6th. So if you have any comments, please submit them by December 6th for consideration in the report. Tonight we'll have a 20-minute presentation followed by question and answer, and then an open house after. We have staff from the board here to help answer any questions, and they'll be up presented in just a few minutes. So just to refresh everyone's memory of where we've been and where we are today, we were here about a year and a half ago, and we did a scoping meeting in Wheaton and Wahpeton to get information and comments from the public on what they would like to see us add for potential changes to the operation of Lake Traverse. Then after we came out for the initial scoping, the team went back to the drawing board and did an analysis and modeling to determine what changes might be beneficial. Then we did a full study of those changes, and we had a second opportunity for public involvement, which we posted on our district website about potential changes and modifications. Okay, and then we're here tonight as my final phase, which is the public outreach and engagement for the draft report, which proposes several changes to the water control manual. So we have 30-day public review period, and then after the public review period, we'll look at all the comments and incorporate any changes. With the final being the approval of this decision document, and then using the information in this decision document to do the update to the actual water control manual itself. Tonight we have several folks from the board that are here, seated at the front table and around the room. We would like to familiar faces for you. Let us know if you guys have any questions after, and we're happy to address them. So tonight, a little bit of who we are, projects, and updates of what's happening in the basin, and an overview of the manual, the analysis that went into the tentatively selected plan, the benefits of that plan, and then next steps. Next time, I'm going to have Wayne here. He'll give us an update about the board.
Good evening. Again, my name is Randy. I'm an operations program manager on the operations side of the board. And just want to give you a quick briefing of who we are on the operations side and what we do. So even broader than this screen you're looking at right now, I'm part of the Recreation and Natural Resource Branch operations. And across the entire St. Paul district, we are responsible for 16 dams, 12 campgrounds, about 45 major recreation areas, and we have 12 field sites spread throughout Minnesota, North Dakota, and Wisconsin. We're focused more on one of our sections we refer to as the Minnesota Flood Control section, and that includes Lake Traverse, which you'll hear more about tonight, but also Black Hawk Project, which is down near Watson, Minnesota, and Orwell Dam near Cedar Falls. And so our areas of responsibility or business lines is what we refer to them as fall under first flood risk management. So within those three project areas, Traverse, Lake Orwell, we operate and maintain 7 dams and flood control structures along the Minnesota River and the river basins. That would include making changes at all those dams, working with our water management folks who give us directions on what changes we may make, debris removal at the dams, debris removal and rapid control structure maintenance. There's a couple of photos there, White Rock Dam, Davis area, and Black Pearl Dam. The next business line is our recreation business line. We operate and maintain 5 Davis recreation areas along the Minnesota River. We have 2 Davis areas at Waldo Dam, which is the Otter Tail River by Fergus, and then 3 Davis recreational sites at Lake Traverse Project, including White Rock Dam, Reservation Dam, and Browns Valley. Most of what we offer at those sites is shore fishing, picnicking, restaurant facilities, that sort of thing. Our third business line would be environmental stewardship. And the Corps owns a fair amount of property in and around our flood control structures. So we do work with controlling invasive species. We have wildlife plots that we maintain. We have out grants with partner agencies, like the DNRs, that may use our property for public access with wildlife management, hunting, and that type of thing. And then one thing that's unique to this section here is we have the district sign shop at Lake Traverse. And a gentleman that does that's sign manager, Allison. They fabricate informational and regulatory signs for 27 Corps of Engineers sites across Minnesota, Wisconsin, and North Dakota. Not only our recreation sites, but also our navigation sites. So that's us in a nutshell on the operations side. Thank you. This is Peter Truax. Sorry, didn't introduce you. I'm going to talk about some of the current projects, specific construction projects. Yep, good evening. So as Randy mentioned, I'm Peter Truax. I'm a project manager of both of the water control manual update project, as well as some construction projects we've got on infrastructure in the Traverse Basin. So one project that we're going to be working on at White Rock Dam is the rehabilitation of the historic gate lifting equipment. This structure was built in the 1930s and has original gate lifting machinery. We are going to be replacing the gate lifting machinery and installing electric actuators to allow for automatic operation gates. We're also going to be installing an operator catwalk over the dam parapet to improve safety and access to the gate lifting machinery. This project will be undergoing construction in the fall of 2025. Highway Category 10 over the dam is going to be reduced to 1 lane during that construction for a couple of months. And there will be periodic closures of the roadway there that will be coordinated by Traverse County and Roberts County as we undertake construction. As a reservation dam in between Lake Traverse and Mud Lake, we will be replacing the air bladders that are the mechanism for controlling the gates on the reservation dam. These have been in place for the last 20 years, reached the end of their service life. So we are going to be using the Army Engineers maintenance here crews to replace these air bladders in the summer of 2025, probably late July, early August. And then that will be over the course of a couple of weeks. There should not be any impacts to the public while those air bladders are being replaced. And Orwell Dam, we're going to be doing chain replacement on gates. That's going to be taking place in the fall of 2025. And then on in Browns Valley, we are doing replacement of a 36-inch culvert underneath Highway 28. And that will be also in the fall of 2025, and will require the closure of the roadway for a couple of weeks while that takes place. If you've got any questions about these projects, I'd be happy to give more details. Next, I'll pass it over to Jason Tidwell, who's going to be talking about the water control manual update.
Thank you. Yes, Jason Tidwell, the primary regulator for Traverse and Orwell. Before we talk about some of the changes we're proposing, it's probably a good idea to review what the current operations are like. course, everybody knows we're talking about Lake Traverse and Mud Lake. Lake Traverse being to the south, more larger lake. Mud Lake is the smaller one north of Lake Traverse. We have three structures. There's Brown Valley Dike, which is a very southern tip of Lake Traverse. Really actively manage that one. Reservation Dam and White Rock Dam. And then we've included Orwell in this map of Lake Traverse because we coordinate a lot of our outflows from Lake Traverse, especially during flood season or during periods where we need to release and be concerned about water quality. We want to try to match good water with poor water for downstream users. The summer operations and fall operations for the project are fairly simple. For Lake Traverse, we try to maintain elevation of 976.8. Now, when the current water control manual was authorized way back in, when it was, we were still using stop logs in Lake Traverse, the reservation dam. And so the stipulation was that we'd have the stop logs in, we would put them at 976.8, but we called the conservation line 976. Now, this can be a little bit confusing as folks really are thinking about the conservation line as 976.8. We're going to talk about some of the changes, but moving that level up on Lake Traverse is one of those things because it's an antiquated way of keeping that conservation level. We don't have stop logs there anymore. We replace those with ladder gates, and so we have a lot more control on the water level at Lake Traverse. Lake Traverse is the largest lake, as you can see on the diagram. The reservation dam is between them. In the summer and fall, we try to keep, right now, Mud Lake at 972. And we have Passive Weir that we are doing that with now. Passive Weir is just we open one of the gates and we have a bulkhead in and the water passively goes over. We don't actively open a gate and close it. It's just whatever can fall over it is what falls over it. And during the fall and the summer, our maximum capacity that we're allowed to release is 1,100 CFS. For the flood season, it's a little more complicated. For flood season, we usually are getting a gauge of what kind of runoff we might get through the snowpack or the snow water equivalencies. We often say we'll often abbreviate that by just saying the SWE. So anytime you hear us say SWE, we're talking about snow water equivalency. And that is usually if you took 12 inches of snow and you were to melt it down, how many inches of water would you have? And it could vary in a snowpack, but that amount of water tells us how much you might expect once it melts. So right now in the water control manual, we have different operations for whether the slow water equivalency is over 3 inches in the watershed or if it's under 3 inches. If it's over 3 inches, our control point, Wahpeton, which is one of the flood control authorizations for the Traverse project, we close White Rock Dam in order to try to, until the peak is passed, and then we can open again. If the speed is over 3 inches, then we wait for the stage of Wahpeton to reach 12 feet. If it's below 3 inches, we wait until it's 10 feet for the stage. Our maximum release rate, even for the flood season, is 1,100 CFS. But I have to say, recent times, we've had so much water in Mud Lake and Lake Traverse that we've had to ask for exceptions to release more because it's threatening the flood level in the Lake Traverse project. So an important feature that this diagram demonstrates is that you have Lake Traverse and the Muskoka flowing into it. It quickly fills up Mud Lake, and it's important to remember that Mud Lake is small. It fills quickly, but drains slowly. Because White Rock Dam is a relatively small opening to drain. In the flood season, when Muskoka flows into the Lake Traverse and Traverse flows into Mud Lake, they both eventually rise in nearly the same elevation. In almost all years, this is the case. And so then White Rock Dam becomes the control during the flood season. And it all depends on what we can get out of White Rock Dam in order to drain the entire project. So it's, as we are talking about the changes that we're going to propose, it's important to remember that about this particular project and that feature, that Mud Lake fills quickly and it drains slowly. The whole project drains slowly for flood season. I put this up here just to give more of an indication. One of the current conditions is now the date, since I put it on here since last week. After the last night's rain, we've had about 2 inches of rainfall in the basin overnight. So right now we're at 976.9 and the pool is still rising. Not sure if we'll need to release from it yet. As I think this hole that's coming right behind it may start freezing things up and creating ice around the edges of the lakes, and that kind of takes water out of the entire equation that we need to delete. But here, as of last week, we were sitting above average in red traps, at elevation 976.7. Despite the fact that we had virtually no rain since August 15th. And this is White Rock Dam. It actually currently sits around 971.1 or so. Maybe it's 971.3 now. But it's below average. And this is partly due to the fact that we had a drawdown in Mud Lake for shorebird habitat beginning August 15th and ending September 15th. So September 15th, we closed the gates to hold back water and try to bring the water back up to 972. Unfortunately, Mother Nature didn't want to cooperate. We had no rain whatsoever since August 15th. So it's a little unbelievable, but it is what happened. But this diagram is just showing you a solid black line on the left-hand side. It's at 971.26. White Rock Dam or Mud Lake is in the 26th percentile, so it's below average, and almost right there at the lowest 25% of all of this vegetation. So it's a little. This I wanted to include just to demonstrate how over the fall we're Traverse County and that our older area is sitting in everyone already knows we're actually in a severe drought. Swat over the past several months. It's been warm, hot, little or no precipitation, and kind of took us from being, I think, no drought into like a moderate drought, severe drought. And on the right-hand side, this shows the average precipitation accumulation for Pelican Rapids, Minnesota, the closest I can find for the weather station. The jagged blue line at the top is the maximum typical accumulated precipitation. The red line is the minimum. In the middle, has this nice smooth green line. That's the average. The black line is our accumulated precipitation at Pelican Rapids up until this point. And then you notice that around August 15th, it goes flat, and that's where we've had nearly zero precipitation. We're on course for having a very average year in precipitation, and then nothing. That's the current conditions we have at the Traverse project. I'm not able to cover all the tiny little details of the summary, but it gives you an idea of what the current conditions are, the current operating rules that we typically are following right now in the water control management. Just have you keep that in mind as we talk about the proposed changes. I'm going to have my colleague take over and discuss those proposed changes. Brett Holgren.
All right, thank you, Jason. So the slide that we have up right here just shows in a picture what Jason just described in the last 5 minutes. So we have the existing operating plan, which we sometimes call a baseline. We're doing some new study. We take the existing and what's there now, we call it baseline, and then we run some usually some reservoir model. So that's what we did for this study. This is our existing plan. Like Jason said, we take a sweet measurement, water equivalent measurement in February, and then we can either go into category 1 or category 2, depending if we have reaches sweet basin. We'll do a drawdown at Lake Traverse over the month of March. The amount of sweet that we have to govern is what we drop down to, and then once after March is we start to have runoff into the pool. Then we look at the stage at Wahpeton, and depending on if it's 10 feet or 12 feet, depending we're in, and we have to close the gates. At White Rock, close it completely, we let out zero flow, until peak is past Washington, and the gates drop that low, that target, and then we release, from White Rock again. At all times, we are not supposed to release more than 1100 CFS. 1100 CFS was, once upon a time, decided to be the channel capacity just below the dam. So if you go up to White Rock Dam and look to the north, you see the big straight channel with riprap on both sides. When that was designed, it was designed to convey 1100 CFS. Over time, there have been some, there's been deterioration of the levees on the other side of the channel, and there are some cases where water will spill outside of the water chute and flood some agricultural lands along the banks. If flows are 1100 CFS, so that's one sort of thing that we studied in our project right now. When we're in non-spring conditions, like Jason said, we mostly just maintain sort of tools for both our reservoirs. One thing to note is we don't have any minimum flow requirements. So we're allowed, according to our existing water control manual, we are allowed to just shut the gates and release this thing into the water chute. And that typically happens during, if it's a dry year, it might happen right after around season. If it's a wetter year, sometimes it's later in the summer. Sometimes we have flow all year if it's really wet. But historically, the water chute has come dry in summer months. So to look at making changes to the water control manual, we performed a study. That study involves using a computer model of the reservoir system. The image on the right is just a screenshot of what that model looks like. So we have Lake Traverse, we have Lug Lake in our model, we have Oro Reservoir in our model, and then we model flows coming down both streams to Wahpeton and then further down the river north. So we end our model at Menlo, and that was one of the changes on the river. With our model, we tested a bunch of different changes to the drawdown of Lake Traverse. How much do we draw down? When do we draw down? We looked at adding a drawdown at Lug Lake. We looked at changing the maximum release limits. Should it be 1100 CFS? Should it be something else? White Rock Dam. We looked at adding minimum flows. We looked at changing stage thresholds at Wahpeton. And then we also looked at how the dam is operated during the really flood events. So there's sort of a there's a bit of a gap in the current water control manual. It's not set up super well for really big events like the 1997 flood, 2009, even 2022. So we wanted to get sort of we wanted to create a more robust set of sort of guidelines for our regulators to follow during those really big floods. And then so once we have all of our simulations, how do we evaluate them? We evaluate them using what we call performance indicators that measure sort of a simulation or alternatives performance when it comes to flood control, dam safety, recreation, fish and wildlife habitat, and water quality. There's sort of 5 metrics that we used. So after we did all of that, all those simulations, there's dozens of simulations that we did, sort of move through a couple of different sort of phases of analysis, where after each sort of phase, we regroup as a team, we evaluate all the results, do a whole bunch of math, and try to figure out, on aggregate, which are the best sort of changes to carry forward, which is the best one to drop. And this is what we came up with. So tentatively selected plan as Corps of Engineers will go for our proposed plan that we would like to carry forward. So that's called our TSP. Our TSP includes a change to the drawdown of Lake Traverse. So right now, in our current plan, our current water control manual, we must draw down Lake Traverse every year. Even if we have no snow in the basin, it requires us to draw down 975.5, so about a foot below what we're trying to hold it at during summer. Our modeling has showed that if we don't have a lot of snow in the basin, doing a drawdown like that really isn't necessary. So if we, what we're proposing is if we have less than 1 inch of snow in the basin, the water movement, we don't do any drawdown at all. And if we have between 1 and 2 inches, we do only a little bit of a drawdown, so not quite as much as we do now. If we have more than 2 inches of sweep in the basin, we're just doing the same drawdowns that we do now. 975.5 and 974.5. The Wahpeton stage limit, so there was, we had a lot of interest in looking at whether or not the stage limit at Wahpeton should change. So to refresh right now, we, let's say we have 1 inch of sweep in the basin is just in sort of our regular drawdown. What Jason would do during the spring is he would look at the stage of Wahpeton, and if it reaches 10 feet, we would have to close the gates, and we'd wait until the river rises and then falls, and once it falls below 10 feet, we can open the gates again. We're not proposing to change that operation at all. We're proposing to keep the 10 feet, 12 feet stage limits. We tried doing model simulations where we raised those, we tried doing simulations where we lowered those, and we found that the 10 feet and the 12 feet was the optimal. Those were the optimal targets. Even though Wahpeton has a levee system now that protects it from river stages, there are plenty of agricultural land between Dam and Wahpeton that would be adversely affected if you change those targets. The third major change that we have in our TSP is changing our maximums and limits. So right now, in our current plan, our maximum release is 1100 CFS. Thou shalt not exceed 1100 CFS at any time during the year. Like Jason said, we've had to do deviations from our water control manual in the past, which is actually water during the spring. So we've had to release more than 1100 CFS. So there are times where releasing more than 1100 CFS definitely makes sense. There are also times where releasing less than that definitely makes sense, especially during the summer. So what we're proposing to do is increase our maximum allowable limit to 1500 CFS during the spring. We're trying to evacuate the spring runoff from the reservoirs. And then once we hit May 15th, maybe a little bit earlier, if it looks like crops are being planted earlier in the season, we'll reduce that to 900 CFS. And our modeling shows that if we keep flows at or below 900 CFS from the dam, that should minimize agricultural impacts downstream. The last change I'll mention on this slide is where it says passive flow over bulkhead, the green box on the bottom. White Rock Dam was originally designed to be able to discharge a very small amount of flow through a low flow opening in the dam. That low flow opening has been abandoned over time because operators had a lot of issues keeping it open. There was three that would get caught in it all the time. So that right now, the way the dam's currently set up, we are not really able to release a very small amount of flow. We can crack the gates a little bit, maybe release about 80 to 100 CFS, but we can't maintain a really low flow out of the dam consistently. So knowing that, we started to take the next best approach. We use what we have, and like Jason said, we close both two of the gates. We keep one gate open, and we put a bulkhead in that gate bay, and we just let water passively flow over the bulkhead. I try to maintain sort of a more gradual lowering of flow in the water stew over time. So that you don't just shut the gates and then suddenly the fish are stranded in the channel below the dam. So the DNR has been really happy with what they've seen, and how we've operated in the past few years. We've been using this bulkhead to sort of just passively let the flow go over the dam until eventually White Lake gets below the bulkhead and flow stops. Which we usually happen eventually, but the point of putting the bulkhead in is just so it flow gradually decreases over the summer. So the benefits that we expect to see if we implement this plan is we expect that there will be lower peak flows during the growing seasons that will reduce agricultural damages. We'll have fewer and shorter periods of low outflow from White Rock Dam. So that will reduce the fish kills, hopefully in the Waterford River. We also, this wasn't on the last slide, but we are proposing that we sort of put in writing the annual drought on a lake that we've been doing for the past few seasons. So during the fall, we draw Mud Lake down to improve shorebird habitat, and then we can put our bulkhead in and then let it fill back up to hopefully provide some good conditions for duck hunting, duck hunting season. Our new plan should also limit the amount of time that Lake Traverse and Mud Lake are really high. So when the two lakes rise during the spring drought period, they sort of become one pool, and we want to reduce the amount of time that they're getting up towards the top of the reservation dam, because if you have a high pool, that increases the risk to the dam. There's a highway that goes along reservation dam, and you can get damage to that and also just sort of general, the higher the pools are, the more risk you have of getting a big storm to come through that raises your pool, and then you start to have some safety increases. So limit the amount of time that the reservoirs are high. We should reduce risk of dam embankments. Our plan, we also think will lower peak outflows, just sort of in general from White Rock Dam. This could reduce the amount of structural damages, flooding of infrastructure in some cases, but in general, we don't expect that to be a huge benefit. We definitely don't expect it to increase, we're definitely not expecting to increase the amount of flooding, houses or other infrastructure. We don't expect a huge decrease either. And then the last benefit, we think that our new changes will keep Lake Traverse an optimal lake level for recreation, sort of monitoring species, and that'll in general improve recreation opportunities. So our next step, as Katie said in the beginning, we're currently in our public review period. So everything that we've shown here is included in our decision document, draft right now, that everyone has the opportunity to review and provide comment on. That ends on December 6th. Right now, we're having our 2 public meetings. We had one last night on the 18th. We've got them. Right now, we're in the 19th, another one, and we hope to have our decision document approved next spring 2025. And then after that's approved, then we can incorporate those changes into a new long-term plan and hopefully have that in place next fall, and then start using it. If you want to share input, you can drop us a comment, you can respond here. We're going to take questions in a second. You can also email us this email. And if you want to access the decision document, you can get it from this QR code on the screen. So I'm going to leave this up. The next slide is just a question slide, but I'll leave this one up to the QR code. And that's the end of our presentation. We'll take questions.
I just have a couple of comments here. I'm understanding that there's also not here, and we're a great team, you guys are great to work with. I like to see it, like, put comments in the board, so to see, what we do is like, that's what that bubble, that we release and also shut down. That bubble will come to an end, that's where it affects. And some homes in danger, so should release it, we should especially a smooth transition, correct? I mean, release and also shut the gates, you know what I'm saying, where you have to release and also shut it, and we have to keep this bubble that goes through, and we want to work with, I mean, like, my questions are, I know a couple of years ago, we worked with you guys, like, we had a rule, you guys were getting a lot more rain on substation down there, we talked on the phone, we wanted to help you, and it seems like it took the allegiance to get it done, get that done, get ready for the flagpole, for you guys, I don't know, so, climate change, like, you guys could have nothing, I mean, inch, we could get 4, or you can get again before you got 3, 4, and you got a half inch, or we can help you, and then the timetable, where you can reach you, not Christmas, we can take all our fire from you, so we don't have the problems, because what happens 3 or 4 days, you ain't coming again for us, then, you know what I'm saying? So is there a way that we can, do the details? You get where I'm coming from, if it makes sense or not,
We're hopefully trying to avoid having to make deviation requests by maybe.
So for example, one of the reasons that we want to, increase CSS is to hopefully minimize the amount of times where we are having to do deviations. So we're trying to incorporate more flexibility into our data plan, so we're not beholden to always operating in a certain way regardless of conditions, right? So being able, giving ourselves, because we legally have to operate according to our measurement. So if we want to say, not down this far, then we have to go through the chain and we have to get a deviation to go through. So we give ourselves a maximum amount of flexibility we can, and that will reduce the amount of times we have to do deviation. In terms of speeding up the process when a deviation does happen, because we'll still probably have to do that occasionally. That's not really in our control. To do.
You see, sorry, there's a 20-mile gap in there, and then, heavy rain, or you're coming out the fields pretty fast, and the rain out,
South going up with 1,500, because I remember when it happened, we were going to 1,100. So you got more discretionary decision making, yes, I can see that it's going to be, you won't have any of those deviations. So, that's what I read before. It made it sound like you guys were doing this to allow operators more flexibility. Did I say that right?
Yep.
Okay. Yeah. This is, I think this is good. So, can I ask some questions?
Sure, go for it.
Public Works Director. Correct me if I'm wrong. Typically, when we start to out, okay, and you guys will start to draw down. Did you guys back that up a month earlier to when you were normally?
Yep.
Typically put that out?
Yep. So that's one thing that I forgot to mention. If you look at right here, it says February 1 to March 31. So if we go back 2 slides, the original existing plan says March 1, March 31. So we are giving ourselves more flexibility, like you just said, to be able to start our drawdown earlier if that's what is happening. If the melt starts to come earlier, or we have just a ton of snow in the basin, we can start it earlier in March 1st to give us more time to actually get to our drawdown, our target.
Yeah, that will help us. If we start to draw down, we've got water through the system, and, we know that when you open that up, not yet, it does help, it breaks up, break up the edges of the river. You can see it, how it starts to erode, it's in the ice and erodes, it's like a channel. You can physically see it happen. So, I think that's good.
Yeah, you might get less, if you open it all up at once, then you get ice jams and stuff that, which causes a lot more damage than, just high flows typically.
Right, yep. So, thank
I'm Randy Chesney with the North Dakota Department of Water Resources. This is not speaking completely for DWR, we do have other comments, but overall, I think DWR appreciates the Corps' effort to improve our water control plan. DWR is recently concerned with water quantity on the HCs of dealing with water quality and such. Like the step approach for the various soil water equivalents. The only concern I have though, and I'm sure that you look at it and we'll have a good answer for it, is if somewhere after February 1st, if we have some major storms on some water equivalents from 1 to 3, 4, whatever the number is, I assume that the Corps would react to that quickly and change their operation plans based on the updated numbers.
Yep. We would try our best. It's a big lake, and can't always get it down, you know, depending on when it starts melting, and you're not always able to get it down where you want it yet, but hopefully if we give ourselves time to start drying down sooner, and then like it says here, the part of the data, read what it says, we'll also do, you know what? We'll do a measurement in January, we'll also do one in February, if we happen to get, you know, a big snowstorm in March, that was also triggers us to draw down our target, that'll be sort of our own discretion. But our intention, whenever we write the actual water control manual, is always to give us, you know, make sure that we're writing it in such a way we have the flexibility to do what we need to do to react to conditions, and not be beholden to a decision that was made, you know, 20 days ago.
Thanks. You said your question is on the lifting gates and the main infrastructure, I know. When they make it seven, should pretty good. Sir, you know, structure and how it is and that.
Yeah, so I just looked at the previous inspection reports from this morning, actually. We don't have really any urgent concerns at the dam. The largest sort of recommendation of last inspection was to replace the I forget the name of the structural member, but one of the structural members for the container gates and repaint the container gates because there's some erosion. But in general, there was no sort of like overall concrete of the structure or anything that would give us concern that it would, you know, fail or anything sensitive. All right. Well.
No, this is completely unrelated to this, but are you guys aware that, you know, the Otter River, how we used to come in right by the traditional Ogden? Well, that would be, our Otter River coming in there is this wall. The Otter River is kind of G channel. Yeah, and it's probably about probably good, yeah, 900 feet, I guess. Hydrogen channel has been kind of bad in there by the last 20 years. So there is really no flow coming in with the original hydrogen right by the ditch. It's cutting in, like I said, I'm 90 feet to the water.
It took out that embankment we had like 5-6 years ago.
Yeah,
we just thought, you know, that's concern. My voice on here, she didn't have all that stuff. They're doing good. There's a nice wall that's getting, they haven't really heard of it. Yeah, no, yeah, they took out that embankment. Back in, it says, it's cut out north.
Okay. Do you know if it still comes in below the gauge, the USGS gauge on the red? It should come in above, I think, it should come in above it.
No, it's sorry. Now it's good.
So it's north.
And I asked. USGS, how is that gonna affect, because you're gonna have that water coming.
So what did they say? Or did they say they're gonna move the gauge?
Oh,
Okay, well, they're the experts.
Uh-huh.
They're the experts on the gauges, but I'll look into that. That's, I don't, yeah, because we definitely wanna know if the gauge isn't reading the. No one else has any more questions on this specifically. We'll be hanging out in the room. If you got any questions, you want me to open up the model, I got my computer back there, so I can show you all this good stuff we're doing, but otherwise, we'll close our presentation and just hang out for a few more minutes. Thanks everyone.
Thank you.